Bismillah. Today we are going to study a very important comparison between the two methods that output an induced electromotive force. And in this comparison, we confirm on the idea of the induction, which is the variation in the flux lines. And here we have two methods through which we can make a variation in the flux lines to output an induced electromotive force. So what are they? What are these methods that causes a variation in flux lines? First of all, the Faraday method that depends on the mechanical step takes place when we move a magnet near to or away from a coil. And here we notice that the Faraday method is a mechanical method. Why is it a mechanical method? This is because it uses mechanical energy to convert its value into an electric energy. On the other hand, we have another method, which is Henry method. In this method, Henry replaces the magnet with with a coil called the primary coil that has a source of energy. And this is the main difference between the two methods. The main difference is the original change of the idea. Here the original change is the flux lines on Faraday method, while here the original change is the current passing through the coil of the primary circuit, known as the primary current. This is the main difference. Okay, let's keep on. So the tool here is the primary coil, and here the reaction also is a point of comparison. Here there is one reaction which is an opposing field to the original field, while on the other hand a complicated opposition takes place because there is two oppositions to the original change. Number one is the opposition of the field, and number two, another current which can be called backward or forward uninduced current. And here in the Henry method, we can notice that the conversion in energy is to convert the magnetic energy into an electric form, and that's why we have examples in our curriculum that expresses what we have just said. This is because the dynamo is an example for the mechanical method of Faraday. On the other hand, transformer or the fluorescent lamp, the fluorescent here lamp are examples that shows the electric method of Henry. And here we have to move to the mathematical part of our comparison. Here the electromotive force in Faraday method with respect to solenoid N delta phi divided by delta T, and with respect to the straight wire BLV sine theta. And here we have to know that the average value of Faraday through quarter cycle is AB and through half cycle is 2AB. On the other hand, we have the mutual induction equations which connects between the primary circuit 1 and the secondary circuit 2, M delta I divided by delta T, where M is the mutual induction coefficient. Don't forget that the cutting variation in secondary equals the field of primary variation multiplied by cross-section area of the secondary coil. In case of self-induction, we here have the self-induction formula, L delta I divided by delta 2. Don't forget that L self-induction has controlling factors. What are they? Represented in the relation mu n square A divided by L. And by this we come to the end of our today's comparison, and that's all for now. All my love, Mr. Nader. Thanks for watching.